Helium neon laser. Helium neon laser. We'll start with the structure of the device. So talking about the construction of helium neon laser, it consists of a quartz tube. It is shown in front of you. So we've got a quartz tube. It is glass discharge tube filled with a mixture of helium and neon atoms. The question is why helium and neon? Because the metastable energy level of both of them are so close. Okay, so we've got a quartz tube filled with a mixture of helium and neon. They are in the ratio of 10 to 1, 10 for helium and 1 for neon, and they are found at a low pressure. It is 0.6 millimeter Hg. So the pressure of the gases inside the tube is 0.6 torr, or 0.6 millimeter Hg, millimeter mercury. At both ends of the tube, there are two plane or concave mirrors. Plane mirrors, okay, or concave mirrors. They are denoted M1 and M2, okay? They are the resonant cavity. And let me remind you with something. The resonant cavity in this case is, yes, external resonant cavity. They are, which are perpendicular to the axis of the tube. One mirror has a reflection coefficient of nearly 99.5%, while the other semi-transparent is semi-transparent with a reflection coefficient of 98%. High-frequency electric field feeding the tube from the outside to excite the helium and neon atoms, or a high DC voltage could be used inside the tube, causing electric discharge. And now talking about operation. Okay. In front of you, we've got a diagram, two axes here. Y-axis, the ordinate, it is for energy in electron volt. It could be 0, 5, 10, 15, 20, 25 electron volt. And we've got energy levels. In this particular laser, 4 energy levels are included in the process of producing laser. Okay? We've got E0, which is the ground state for helium and neon. And we've got E3, which is metastable energy level of helium atoms. Okay, there is something very important. Since the metastable energy level of helium is so close to that of neon, okay, what happens? When, yes, a metastable energy level helium atom collide with a ground state neon atom. Okay, excitation energy is transferred from helium into, yes, neon. So we've got neon, and excitation energy is transferred from helium to neon by collisions. And talking about neon, we've got, yes, the ground state. They could be in the ground state, and E1, and it is a normal energy level, and the metastable energy level E2, which is very close to that of helium atoms. Okay, and moving from E1 to E0 is a rapid decay. and we'll obtain laser when we obtain, yes, population inversion in E2. Okay, and we'll obtain laser of wavelength 632.8 nanometer. We'll explain this one by one. Okay, so let's start. Pumping in this type of laser is accomplished by setting up an electric discharge in the helium-neon mixture. Pumping is the process of imparting energy to the active, yes, or the lasing medium. Electrons and ions resulted from this discharge collide with helium atoms, raising them to the energy level E3. It is a metastable energy level. E3 is the metastable energy level of helium atoms. This level is a metastable energy level. E3 in helium, which has got energy 20.61 electron volt, is by chance very close, yes, to the energy level in neon, which is E2. There is a subtle difference. In helium it is 20.61, in neon it is 20.66, yes, electron volt. So when a metastable helium atom and a ground state neon atom collide, and this collision is inelastic collisions, what happens when they collide? The excitation energy of the helium atom can be transferred to the neon atom. In this way, level E2 becomes more heavily populated than E1. We call this, yes, population inversion situation, which is very essential for stimulated emission to be predominant and to obtain laser. E2 becomes more heavily populated than, yes, E1. This population inversion is maintained because the metastability of level E3 ensures a ready supply of neon atoms in level E2. Atoms in level E1 decay relaxes rapidly to the neon ground state. Okay, some neon atoms in level E2 spontaneously fall to E1. In so doing, they emit stimulating photons, photons of energy, which stimulate some neon atoms to fall from E2 to E1 before their lifetime is over. Most of the stimulated photons initially produced in the discharge tube will not happen to be parallel to the tube axis. They will not be parallel to the tube axis. They propagate randomly in all directions and will quickly be stopped at the wall of the tube, at the tube walls. Stimulated photons that are parallel to the axis are made to move back and forth through the discharge tube by successive reflections from mirror M1 and mirror M2, so that a great deal of stimulated photons are produced. In this way, amplification takes place. When radiation inside the tube reaches a certain level, laser light, yes, issues out, leaks out through the semi-transparent mirror. Note, neon is the lasing medium, is the active medium, is the material from which we'll obtain laser. Metastables of helium and neon are of very close values, and that explains why they are used to produce laser light. Let me say it again because this is very important. Metastables of helium and neon are of very close values, and yes, this explains why they are used to produce laser light. And now talking about laser applications. Laser is used to produce holograms, three-dimensional pictures. So they are used to produce, yes, holograms. Okay, and it will be shown in front of you. Because laser can concentrate a lot of energy onto a very small area, laser is highly intense, so we can concentrate a lot of energy on a small area. So laser can be used to drill into metals, even in diamonds. They can be used to drill into metals, even in diamonds. Lasers can be used as cutting or welding tools in delicate eye surgery. Let me say it again. Lasers can be used as cutting or welding tool in delicate eye surgery. Because laser is highly directional, because of collimation of laser light, laser has military applications such as precision guidance in smart pumps and laser radar, we call it LiDAR. Lasers are used to guide bombs and missiles in recent conflicts. Also, laser has applications in art and laser shows, surveying, determining dimensions and areas, and space research. In long-range communication, laser beams are used instead of electrical signal carrying wires, because signals travel along optical fibers with less loss and are also immune to electromagnetic interference. In industry, particularly fine industries, CD reading, laser printing. Note, because laser can concentrate a lot of energy onto a very small area, it can concentrate energy, a lot of energy on very small area. It can be used for cutting. It is focused with a lens. If it is focused with a lens, the laser can cut through metals such as steel quite easily. It can even cut diamond. Of course, it doesn't really cut. It vaporizes the material, on which it is focused. A laser knife can be used for surgery. The energy of the light, the laser light beam, instantly boils any cells, on which the light is focused. No infection can be caused, and the wound seals under the heat, so little or no bleeding occurs. They are used to adjust the curvature of the cornea to correct defects of vision. To differentiate between laser light and normal light. So let's make a comparison between laser light and normal light. Okay. First of all, we'll try to differentiate between the two types of light, laser light and normal light, by, experiments. We could use Young's experiment. In Young's experiment, if a white light is passed through the two slits, an interference pattern of colored fringes is produced on the screen. This if we use white light. Okay, so we are differentiating between laser light and normal light by using Young's experiment. If a white light is passed through the two slits, an interference pattern of colored fringes is produced on the screen. Now, if we illuminate the two slits with a laser, the interference pattern appears as a set of alternate bright and dark fringes. If a normal light fell on a prism set in the position of minimum deviation, so the second method to differentiate between a normal light and laser is by using a prism set in the position of minimum deviation. If a normal white light fell on a prism set in the position of minimum deviation, it would disperse into 7 colors. But laser is monochromatic light, so yes, no noticeable dispersion occurs in case of laser. Okay. Third method to differentiate between, normal light and laser. In ordinary light sources, the diameter of the emitted beam increases with distance. While in laser light, the diameter stays unchanged for long distances without much divergence. And now, let's answer some questions. We'll start with give reason. Laser light does not obey the inverse square law of light. Give reason. Laser light does not obey the inverse square law of light. Okay, because laser light has high monochromaticity. That is to say, it has a very small bandwidth, a small frequency band. Laser light has high collimation, that is to say it is highly directional. Also because laser light is coherent, photons of laser are in phase. So laser is very intense light, that explains why it doesn't obey the inverse square law of light. Give reason, laser light is highly monochromatic. It is all easy for you because all the photons of laser light have almost the same energy. They have the energy which is the difference between ground state and excited, E2 minus E1, which is equal to h nu. And hence, they've got the same frequency and they are of one wavelength. That's to say, the bandwidth of laser light is very narrow. Note that the transition of electrons between only one pair of energy levels in one type of atoms is involved in laser. Give reason. A mixture of helium and neon gases is used to invent a gas laser. Why helium and neon in particular? Because the metastables of helium and neon are of very close values. Metastables of helium and neon are of very close values. Thus, when a metastable helium atom and a ground state neon atom collide, the excitation energy of the helium atom can be transferred to the neon atom. In this way, a population inversion situation is reached, is obtained, where there are a much greater, in population inversion situation, there are much greater number of neon atoms in E2 than the atoms in the ground state E0. Thus, the stimulated emission becomes predominant and laser light is produced. Give reason. The presence of a totally reflecting mirror and a slightly transparent mirror in the helium neon laser. They lengthen, they increase the length, they lengthen the path of the stimulating photon to increase the number of the stimulated photons. And this way, the intensity of laser light is built up. Intensity is amplified. Also, they improve the spectral purity. It is called monochromaticity. The mirrors improve the spectral purity and the collimation of the beam, laser beam. Also, laser leaves the device from the slightly transparent mirror. Give reason. High frequency voltage is connected across the two electrodes of the helium neon laser. Why there is high frequency voltage? When a sufficiently high voltage is applied, a discharge occurs. So when a sufficiently high voltage is applied, a discharge occurs. Collisions between ionized atoms and electrons, electrons carrying the discharge current, excite the atoms to various energy states. Give reason. 4. Laser is a very useful tool for surveyors, especially in situations where great precision is required. Okay. Simply because laser light has high collimation. Laser light is highly directional. That's to say, the photons in a laser beam are strongly correlated in their directions. A laser beam can travel long distances without appreciable spreading. Give reason. A population inversion situation is essential for laser action to take place. Why this particular situation is so important, so essential? Population inversion situation is essential for obtaining laser, for laser action to take place. Thank you very much. When a population inversion is obtained, there is a much greater number of atoms in the excited state than in the ground state, and this makes stimulated emission predominant. So we want to make stimulated emission predominant, and laser light then is then produced. Give reason. Laser light can be used for cutting through metals. Laser light can be used for cutting through metals. Because laser can concentrate a lot of energy on a small area. When it is focused with a lens on it, laser can concentrate a lot of energy on a small area. Laser actually vaporizes the material on which it is focused. Give reason. Laser light is suitable for use in surgery in some certain cases. Because laser can concentrate, as I said, a lot of energy on a very small area. Laser beam is very intense, so it concentrates a lot of energy on a small area. The energy of the light beam instantly boils or vaporizes any cells when it is focused on them. No infection can be caused, and the wound is sealed under the effect of the heat produced. It is used in surgery in place of knife to cut flesh with little loss of blood. Laser light is collimated. Give reason. Laser light is collimated. It is highly directional. Because all the photons of laser light are in phase, and they emanate at the same time and place and maintain the same phase during propagation over long distances. That is to say, laser light is a narrow beam of parallel waves with very small angle of divergence. Give reason. Laser light is valuable in producing interference pattern. Laser light is valuable in producing interference patterns. The single wavelength of the laser light makes it valuable in producing. So it has, or this is because laser light has single wavelength. The single wavelength of the laser light makes it valuable in producing interference patterns, especially because laser light is coherent. That is to say, all of its photons are in phase, are in step. In this way, we've come to the end of this edition. Until we meet again, my best wishes to you all. Thank you very much.